In this video, we're going to go a step farther. In the last video, we talked about how to find mirror lines, but mirror lines aren't the only kind of features that patterns have. They have other features as well, and in order to write the Orbifold signature that each different pattern has, we need to identify what those other elements are. We're going to be looking for centers of rotation, we're going to be looking for translations, and let's get started.
Okay, so here are the lines of reflection that we found in the first video, and here is the region that we enclose with our mirror lines. And this region will end up being our orbifold. In this case, there are no other symmetries, and we want to indicate that we have a kaleidoscope by using this symbol, a little asterisk, to indicate a kaleidoscope. In this case, we have three different corners, or three different vertices, and each of those is going to have rotational symmetry as well. These mirrors also generate rotational symmetry. So we're going to label the rotational symmetry of each vertex. So in this case here, you would have to turn it 120 degrees to get so it looks the same again. So this has order 3 rotation. So right next to that vertex, we're going to write a number 3. Likewise, this vertex, although it's different from that one, if you look at the pattern around it, it doesn't look the same. So these are actually distinct points. So this one also gets a number 3. And finally, this point right here is different from these other two, so it also gets a number 3. And in this case, we don't have any other symmetries other than this, so that completes the signature of this one. And we write it with that star first, star 333, 1, 3 for each of the different point centers of rotation. Now, it can happen that we can have more than one point that actually ends up being the same. So in this case, we still have a kaleidoscope. So we're still going to put the star. But if we carefully examine each vertex here, even though they are different points now, they really are the same part of the pattern. And ultimately, we really still have 4 copies of the pattern in between these mirror lines. So although we have these 4 points, we're only going to label one of them. And in this case, we're going to label it with the number 2, because this is just 180 degrees symmetry here. You have to turn it all the way around 180 degrees before it looks the same again. So it is order 2, meaning that 2 positions before you get back to the same place. Now this signature is not done. Star 2 is going to be part of the signature, but there's going to be more to the signature than just that, because we have more symmetries that we haven't identified yet. There's a third possibility, which is shown here, where now we have parallel mirror lines and no intersecting mirror lines at all. So in this case, our kaleidoscope doesn't have, you couldn't build a physical version of this because these lines are infinite, and we would have infinite parallel mirrors, but we're still going to consider this a kaleidoscope, and we are going to label it with a star. Now in this case, there is another symmetry here that's a little bit harder to see. If we take a look at this little swirl right here, and we look at the tip of this swirl right here, which I'm going to put a little dot there, we can find that same feature of our design again and again. Notably, we can find that feature right here. If you look carefully, it is actually flipped over as if there is a mirror image. But in this case, there is no mirror line. There's no mirror line between here and here. So somehow this motif has flipped over without actually being reflected in a mirror line. And when this happens, this is actually a glide reflection, but we're going to indicate that with a dashed arc which joins those 2 points, and we're going to label that with an X. So anytime we can go from one point to a copy of that point that's flipped over without crossing a mirror line, we're going to label that with an X. Conway calls this a miracle because we have a flip without an actual reflection. It's really a glide reflection, but we're going to call it a miracle, and we're going to use this symbol X. So in this case, this particular pattern has some reflections and some of these miracles. So the signature of this pattern is going to be star X. Now sometimes we can have gyration points or rotations that are not generated by reflections. So in this case, if we look in the middle here, we're going to revisit this pattern. If we look in the middle, there is a gyration point here, meaning that there's a point where there's rotational symmetry around this point, but there are no mirror lines. So this we're going to call a gyration point, and in this case, this is a gyration point of order 4. In other words, we have to rotate the pattern 90 degrees before it looks the same again. So we're going to put next to that point, we're going to put the number 4. And in this case, I'm using a blue mark because Conway distinguishes between the reflecting red marks, in other words, the transformations that are order reversing, and those that are order preserving. And in this case, these are rotations where the orientation is not being reversed. The orientation is staying the same. There's no flipping, in other words. So there are no other transformations here. These 3 things will make this pattern, gives us everything we need to repeat this pattern over and over again. So the signature of this pattern will be first the blue numbers, so it'll be 4, and then the red symbols, which in this case is that star and then 2. There's one last possibility. If you look at this particular pattern, we don't have any reflection lines, we don't have any mirror lines, and we don't have any gyration points either, and there's no miracles. There's a point here and one here that look identical, but it's not flipped over. I can also go from here over to here, and there's another point that also is identical, but again, it's not flipped over. So in this case, when we can move from one copy to identical copies in 2 different directions, but there are no rotations and no reflections, we're going to, this is a special case where the Orbifold signature will just be an O. We're going to call this a wander, and Conway calls it a wonder ring, or a wander ring, or a wandering. In this case, that's the entire Orbifold signature. There are no other transformations here that will carry the figure onto itself.
So kind of summing up from this last video, what we've been trying to do is write the Orbifold notation for each of the designs we have. And so it's kind of important that we do what we do in a certain kind of order. The first thing we should do is look for mirror lines. And then after we do that, we should label kaleidoscopes with a star. So basically, anytime we have mirror lines, we have a kaleidoscope, and anytime we have mirror lines that we mark, we're going to put a star. The next thing we should do is label each different vertex with a number corresponding to its rotational order. Finally, we're going to look for miracles, a flipped over copy of a point without a reflection. And those are the ones we're going to identify with red marks. Then we're going to switch to blue, and we're going to find gyration points and label them with a number corresponding to their order. And finally, if everything else fails and we don't have any of these patterns, we're going to mark it with a wonder ring, because that's where it just has translations to get from one place to the next. So now that we know how to do those, the next video is going to show you a game that we're going to play to start beginning to recognize what these different orbifold notations are.